Welcome to the Deep Dive. If you're here, you're looking for a shortcut to being well-informed. And today, we are diving deep into what I think is one of the most critical paradoxes of the 21st century.
It really is. We're living in this so-called AI era, a moment of just exponential data creation.
Right. Data is everywhere.
For years, we've talked about the problem of information overload, just, too much data being created.
Right.
But what if the real crisis isn't having too much data, but the threat of losing the invaluable parts of it? We seem to be accelerating toward what some experts are calling the digital dark age.
That's absolutely right. And it's a warning that comes straight from the top. I mean, Vint Cerf, one of the founders of the internet, he's been sounding this alarm for years.
Right. I remember hearing him talk about this, and it really stuck with me because it's not just one problem. It's like a twofold crisis that basically guarantees failure sooner or later.
Mm-hmm.
First, you've got the most obvious thing. The physical media itself just degrades. Whether it's the magnetic pulses on a tape or the tiny little pits on a CD or a Blu-ray.
Yeah.
They're not permanent.
They're just not. They're subject to chemicals, to the environment, they break down. And then there's the second problem, which I think it's almost more insidious. It's what we call reader obsolescence.
Oh, this is a huge one.
It's the simple fact that the hardware you need to actually read the media just disappears.
Yeah.
I mean, think back to the 80s or 90s.
The giant 5.25-inch floppy disks.
Right, and then the smaller 3.5-inch ones. Trying to find a working, reliable reader for those today is, it's almost impossible outside of a museum. And even those readers are fragile antiques themselves.
And we're not just talking ancient history. I mean, you see this with zip disks, jazz drives, even old data tape formats. If your critical data is locked on that thing, it's effectively gone.
It's a ghost. But, the crisis actually goes even deeper than the hardware. This is the part that Cerf pointed out that I find most frightening. Even if, by some miracle, you preserve the media perfectly and you somehow find a working reader in 50 or 100 years, you hit the interpretation crisis.
The software.
The entire software stack.
Yeah.
The file format, the operating system, the application you need to make sense of those bits and turn them into, say, a photo or a spreadsheet.
It's gone. Or it's completely incompatible with whatever future system you're using.
Exactly. So you have the raw data, the ones and zeros, but you have no dictionary. You have no decoder ring to make sense of it. It's like finding scrolls from the Library of Alexandria, but the language is totally forgotten.
The information is functionally extinct.
Precisely. Archivists, they try to patch this with things like emulation running old software on new machines, but it's incredibly complex. It's not systematic, and it definitely can't scale to handle the massive amounts of data we're creating.
It's honestly humbling when you compare our supposedly advanced digital media to the ancient stuff. A good hard drive, if you're lucky, might last a decade, maybe two, under perfect conditions.
And that's the best case scenario. Now, contrast that with something simple, like an ancient clay tablet.
Right.
They weren't even meant to be permanent archives. They were just, receipts. But when the building they were in burned down, the fire accidentally baked the clay.
Making them permanent.
And 5,000 years later, we can still read them.
And the key metric for their survival is simplicity. It's direct visibility. You can just look at it.
That's the key. The ability to see the information without a complex machine. That's the metric we lost when we went digital, and it's the one we have to get back.
We are already talking about the active installed base of enterprise data hitting 6,693 exabytes.
What is an exabyte?
An exabyte is a billion gigabytes. So to try and visualize 6,693 of them, that amount is like storing the entire Netflix global library over 1.3 million times.
That is monumental, and that's just where we are today.
And that's the scary part. This is just the beginning of what analysts are now calling the yottabyte era. We're talking about data volumes measured in septillions of bytes.
So that preservation problem is really reaching a breaking point.
It is because that installed base is set to just explode. Annual shipments are projected to climb to 57,311 exabytes.
Per year.
Every single year by 2050. And if we keep managing this ocean of data using short-lived media that demands constant, costly migration, the whole system will collapse under its own weight.
Financially, ecologically, logistically, all of it.
All of it.
So that really defines our mission for this deep dive then. How do we solve this fundamental digital preservation challenge? It seems like we need a clear path forward. Moving into zettabytes and beyond, it's a staggering amount.
It is, and we're going to do this by looking at two sort of complementary solutions.
First, we'll analyze a really revolutionary physical storage technology called DOTS. And it's pronounced just like the word dots. It's designed to meet that ancient archivist's standard for survival.
And then second, we'll see how that kind of ultimate permanent storage layer can integrate with a modern active archive system like Iron Mountain's Smart Vault, which uses Google Cloud and Gen AI to unlock the value in all that data. So let's just start with the scale of this. The sheer amount of data loss risk we're facing. We're creating data at this just exponential pace. The numbers are almost impossible to grasp, hundreds of exabytes.
They really are. And the consequences if we fail they're existential. Not just for a company, but for our culture, for our legal systems. The Digital Preservation Coalition, the DPC, they highlight these risks across the board.
And what are they?
Well, you have massive data loss and corruption, obviously. Yeah. Just losing the record. But then you have the inability to meet legal or regulatory requirements. That means huge financial liability.
And damage to your reputation, right? If a company loses critical customer data or its own intellectual property, that can be irreparable.
Absolutely. And on top of that, there's the crushing economic cost of just trying to survive this obsolescence. Organizations are forced to maintain these super expensive old legacy systems just because their data is trapped on them.
And here's a detail that really highlights the problem for me. Most of this new data that enterprises are creating, it's completely unmanaged. It's sitting in the dark.
That's the dreaded dark data. Some estimates say that 85% of enterprise data is unstructured. That means documents, videos, emails, images, stuff without clear metadata. Companies don't even know what they have.
Let alone how to save it or, how to actually use it in the future.
And we're trying to store all of this on magnetic media, which is, at its core, short-lived. It was designed for performance, not for permanence.
What are some of those specific vulnerabilities?
Well, physically, you've got chemical degradation. The binders that hold the magnetic particles to the tape just break down. You get delamination where the layers separate, oxidation.
And that's all made worse by heat or humidity.
Right. And then there's the environmental threat. Magnetic media is incredibly vulnerable to a hostile electromagnetic environment. A powerful enough EMP, an electromagnetic pulse, could instantly scramble or just erase everything.
So this systemic reliance on magnetic media leads us straight into what the archivists call the migration trap.
It's a self-perpetuating system. It's built entirely on planned obsolescence and continuous cost.
Let's really unpack that because it feels like the engine that's driving this digital dark age. Our current strategy is just forever migration.
It is. We're just making copies of copies of copies, usually on these forced 3 to 5 year refresh cycles, just to keep up with the next format or because the old media is decaying.
And while that's great for the IT provider's revenue,
it comes at a massive cost, both to the clients and to the planet. These giant data centers, the spinning disk and SSD farms, they require a staggering amount of energy in HVAC 24/7 just to maintain the perfect environment.
And the sources really emphasize how unsustainable this is. This cycle creates what they call massive waste. Every time a hard drive or a data tape dies, it goes to a landfill. Mountains of e-waste.
And beyond the waste, there's a fundamental risk to the data itself.
Before we get to the solutions, I think we really have to grasp the stakes here. There's a brand new threat, one that we have to call the AI provenance crisis.
This is so critical. We're talking about the potential for, well, a bad actor or even just an AI system to alter an original uncompromised source file. If an AI is trained on data that's been manipulated, or if a master file gets corrupted somehow, it just raises these massive issues for authenticity, for legal records, for historical truth.
This is where I start to worry about relying only on digital checks. I mean, we have promising solutions, like C2PA, which can flag if a file has been altered. That's a great tool for detection.
It is, but
if the original source file itself has already been changed, if the AI manipulates that first generation C2PA, can't just rewind the clock, it can't bring back the true source.
Exactly. The original is just gone. And that really highlights why just relying on software isn't enough for true long-term preservation.
And this is where that DOTS technology comes in, because it seems to be designed specifically to meet that ancient archivist's metric.
It is. The archivist's perspective, which has been honed over literally thousands of years, is very clear on this. The only successful way to guarantee provenance and long-term survival is to use media where you can literally see the information.
Let's start by looking at the historically proven media film. Archival film has been the gold standard for over 120 years because it's simple to interpret.
Right.
All you need is light and a lens to project it or view it. any mechanically inclined person anywhere on Earth could build a reader or a viewer with simple components. That is the definition of simplicity.
And the DOTS technology, it adopts that same philosophy, but it substitutes the, let's say, volatile chemistry of film with something chemically inert and non-magnetic.
Exactly. The data recorded on DOTS media is visual. It's microscopic patterns of light and dark, not magnetic impulses.
Just like film.
Just like film. And retrieving that data just requires light and a lens, a camera, using standard image processing techniques that are available anywhere.
And crucially,
the patterns are large enough that a human could actually interpret the information with sufficient magnification. It completely fulfills that visual and simple mandate.
okay, that's a powerful start, but the host in me has to challenge this. Film was simple, yes, but it was also incredibly bulky, unstable, and it had massive preservation costs.
Huge costs.
So how does DOTS improve on those physical downsides, especially when it comes to density and longevity?
And that's where the modern engineering comes in, delivers these exponential improvements. So let's take density. When companies like Kodak were experimenting with storing digital data on 35mm film, they found they needed over 200,000 feet of film.
200,000 feet.
A massive physical archive, a stack over 12 feet tall, spread across 120 reels, just to hold 8 terabytes of data.
Just the physical footprint alone makes film totally impractical for the zettabyte era we're in. A single 12-inch reel of 35mm wide DOTS media can hold over 37 terabytes.
That's a huge improvement.
It is, and their design philosophy was really clear. They decided to trade off what you might call inordinate data density, the absolute bleeding edge for inordinate data security and longevity. Contrast that with everything we use today: magnetic tape, optical discs, even holographic storage. You have to have a specific proprietary machine and complex software to read the data.
And this commitment to physical simplicity is it's solidified by what they call the simplicity guarantee. And this addresses Vint Cerf's fear of reader obsolescence head-on.
Right, the idea that the instructions on how to access the data had to be preserved with the data itself. How does the DOTS system do that? How does it ensure that backward compatibility for centuries?
Every single DOTS tape has an embossed pictogram and a Rosetta leader.
A Rosetta leader, I like that.
And this leader contains instructions. They're printed microvisually, but you can interpret them with magnification. Instructions on how to view the data patterns, how to interpret them, and this is a stroke of genius, it includes instructions on how to build a basic DOTS reader.
Wait. They embedded the intellectual property needed to access the data directly onto the physical archive medium itself?
That's right.
That's like storing a textbook inside a safe, but also including instructions on how to build the lock-picking kit right there with it.
That's the perfect analogy. This ensures that even if the original manufacturer were to vanish tomorrow, the data is still accessible for centuries. That brings us to what might be the most sophisticated part of this technology, especially for visual archives. This patented bitplane image preservation solution. This seems to tackle that interpretation crisis head-on.
It does, and it's the profound solution. It's a method that is designed to completely remove all dependency on file formats and operating systems for images and sound. It prevents your files from becoming digital orphans in the future.
So instead of saving a complex file like an MP4 that needs a specific decoder, how does it save the image data physically?
It breaks the image down into its most basic components, the raw color data at the binary level. It represents each bitplane of the 3 color channels, red, green, and blue, as its own separate binary image array on the tape.
Okay, walk me through that. So for a single digital picture, the system isolates, say, the first bit for the red channel for every single pixel and saves that pattern of ones and zeros as one binary image.
Exactly. If your image has a common 10-bit color depth, you'd end up creating 10 separate binary image arrays for the red channel, 10 for green, and 10 for blue. So 30 binary images for a single frame of video. To restore the full red color information, you simply apply the logical OR to combine all of those bitplanes.
That's the key. The logical OR algorithm is the simple, transparent math that rebuilds the image perfectly.
And you repeat that for the green and blue bitplanes using the same logical OR function.
It essentially layers the value of each bit position back into the pixel.
This approach guarantees that the provenance of the image or sound file can be verified in the distant future.
And that guarantees readability for centuries because you're not relying on any complex file headers or metadata. You're just left with the pure, raw, visual information. For anyone listening who wants a really detailed step-by-step breakdown of how that binary conversion and stacking works, we'll put a link to a great layperson's explanation in the comments.
It's definitely worth a look if you're curious.
But a concept this revolutionary needs serious validation, right? Especially from organizations that can't afford any risk.
Absolutely. And the crucial step in proving this was a proof of concept for the U.S. government. Specifically, the CIA awarded a contract to Group 47 to build and demonstrate a prototype of the DOTS system.
Why the CIA?
Well, they operate with the absolute highest security archival needs. The contract was designed to get formal certification that the technology works as advertised. They were. The CIA certified that the technology works. They proved successful writing and reading of standard document data, and, critically, they validated the writing and reading of data using that special bitplane image preservation format. It was a huge validation.
Now, when we talk about this level of ultimate permanence, we have to talk about the trade-off, which brings us back to that analogy we love.
You don't plow a field with a Ferrari.
Exactly. High performance, hot data that you access every second needs the blazing speed of an SSD. But archival data, the cold stuff, just doesn't need that.
And the data supports this. More than 70% of all enterprise data is classified as archive or cold data.
Yeah.
It has no need for microsecond access times.
So what is the need for an active archive then?
It's about consistent access.
So you're saying we accept that for the vast majority of our data, we don't need the complexity and energy drain of high-speed systems. We prioritize immutability and long-term survival instead. Okay, so if 70% of data is cold and has a permanent home in something like DOTS, what about the rest? And what about all the legacy media that still needs to be digitized? We still need that fast access and intelligence.
This is the other half of the modern challenge. You need systems designed for high-level accessibility that can turn all that dark data into searchable gold.
I know for years clients faced these huge roadblocks when they even thought about digitizing their old collections, right? The stuff sitting on videotapes or film reels in vaults.
The sheer volume was one problem. But the biggest issue was ambiguity. They just didn't know what they owned, so they couldn't calculate the return on investment. For many, just doing nothing and leaving it in the vault was the most viable option.
But then something changed, and the consistent rationale that changed everything was generative AI.
Gen AI was the pivot point. It finally justified the massive cost of migration and digitization, because clients could see how it would unlock the value in their archives.
Suddenly, you could instantly search through millions of hours of video or summarize footage or find assets to monetize.
Right. Seeing the leap forward in tools like Google's Gemini and Vertex AI gave organizations the confidence to finally move forward.
And this convergence of logistics, archival knowledge, and AI is exactly what led to Iron Mountain launching Smart Vault in partnership with Google Cloud.
Smart Vault is Iron Mountain's digital archive product, and it's optimized specifically for handling these massive collections of video, audio, and stills, all that unstructured dark data.
What are the key features that make it work as an active archive?
Well, you have secure storage, seamless access, massive scalability, and critically robust chain of custody tracking. This is essential. They're handling irreplaceable physical media, and the client needs to know its journey is documented every step of the way.
And the goal is to activate the archive, to make that cold data usable.
Exactly. Users get intuitive search, a really useful storyboard thumbnail view for previews, and the ability to order clips or full files. It's designed for active use.
But the truly transformative part is that Google Cloud partnership and the Gen AI. That's what turns the dark data into intelligence.
It's a complete end-to-end solution. Iron Mountain handles the physical logistics and scanning. The digitized files go to Google Cloud, and then the Gen AI tools are immediately applied.
And how does that AI actually create the value? What is it doing?
It generates incredibly rich metadata. It does things a human archivist could never do at scale. We're talking complete audio transcription, content summarization, optical character recognition on any text in the frame.
And complex identification services.
Yes, like identifying celebrities, specific objects, locations, even logos within the media.
Yeah.
This AI-generated metadata becomes the engine for discovery. You can suddenly search for anything that actually appears in the content, not just what someone wrote on a label 50 years ago.
And when all this data lands in Google Cloud, they have to manage the cost, which is where the tiered storage architecture comes in.
Right. Google Cloud has different tiers. Standard for hot data, nearline for less frequent access, cold line for quarterly access, and then archive for yearly access, which has the lowest cost.
And the system manages this automatically so the user doesn't have to.
Automation is key. Features like AutoClass and Object Lifecycle Management automatically move data to colder, cheaper tiers based on how often it's used. It's a seamless way to balance the need for access with the need to control costs.
Which brings us right to the money. The economics of forever. You've got the constant operational expense of the cloud versus the one-time capital expense of something like DOTS. We have to use total cost of ownership, TCO, as the metric here.
Absolutely, because the initial price tag is deceptive. TCO is where technologies like DOTS really shine because they just eliminate these massive recurring operational costs. No more constant migration, no more insane power and HVAC bills.
If you look at the requirements for magnetic media storage, like at the National Archives, the environmental controls are enormously expensive to maintain decade after decade. DOTS just gets rid of that.
And the energy savings alone are staggering. The projections show that by 2035, these emerging storage technologies will use 1,000 times less energy per terabyte than SSDs. That is a massive cost avoidance over a 50-year lifespan.
And the cost comparisons show this clear trend. SSDs are still projected to be relatively expensive per terabyte for cold storage in 2030.
Whereas emerging tech like DOTS is projected to be much, much lower.
So what about the big elephant in the room? Cloud archive solutions like AWS Glacier Deep Archive. A lot of people see that as the cheapest option. At what point does an on-premise system like DOS actually become cheaper?
If you look at the total cost of ownership chart for archiving 1 petabyte of data, the results are very clear.
We're talking about TCO over a long period.
Exactly. The crossover point where Amazon Glacier Deep Archive becomes more expensive than DOT depends on the region.
So the costs aren't uniform across the cloud provider.
They are not. If you store your data in the Amazon Glacier Deep Archive US West Zone, the crossover happens in less than 6 years.
Less than 6 years. It's a very short time horizon to see a TCO advantage.
It is. If you're using the Amazon Glacier Deep Archive US East Zone, it takes a little longer, but still less than 10 years.
So in less than a decade, on-premise DOTS is cheaper than either of those major cloud archives.
It fundamentally changes the economics of archival storage, especially at the petabyte level.
And that's all due to eliminating the migration cycle and the huge costs of environmentally controlled storage, which the cloud provider still incurs.
The whole enterprise storage market is starting to recognize this. It's shifting toward active archive technologies. Things like DOTS, Terabyte, Microsoft's Project Silica, they are all prioritizing what we call SIS, sustainability, immutability, and security.
Over just raw speed or density.
Over mere speed or density. It's a huge shift in thinking. It's a paradigm shift from paying to keep your data alive to paying once for the data to be alive indefinitely. What's so fascinating to me about this whole deep dive is the synthesis. The greatest data challenge in human history requires two completely opposite solutions.
Right. We need one for rapid intelligent access that uses cutting-edge complexity like Gen AI, and another for simple geological time preservation that uses nothing more complex than physical marks.
It forces us to reconcile our modern desire for complexity and instant gratification with the historical truth that simple, visible, physical things are what survive. All you ever needed was a light and a lens.
Our current model, that migration trap, is just this cycle of perpetual, complicated effort. It generates massive waste, all to just delay the inevitable failure of the media.
So we need to adopt a storage philosophy that actually mirrors the data's long-term value. So if the ideal solution involves having both immutable provenance, like what DOTS offers, and immediate intelligence and access, like what Smart Vault and Gen AI offer, what combination of these technologies will ultimately win the yottabyte era race?
That is the fascinating two-pronged challenge. Will we see immutable physical storage become the certified, non-negotiable original source, the master copy that can never be compromised, which then feeds intelligent, ephemeral cloud platforms for active, everyday use?
It's the challenge of marrying the past's need for permanence with the future's hunger for performance.
Indeed. You have to decide which data needs the ironclad guarantee of truth and which data needs the instant, monetizable intelligence of the cloud. The two cannot coexist in a single medium today, but they must coexist in a single strategy tomorrow. They aren't competing, are they?
Not at all. They are entirely complementary. They solve two different but equally necessary problems.
Smart Vault, with Google Cloud's AI, is focused on the active, accessible layer. That's the speed and the searchability you need to monetize your data and find what you have.
And DOTS is focused on the immutable, permanent layer. It is the ultimate worm, air-gapped master copy. It guarantees the provenance of that original file for centuries, protecting it from physical decay and from any cyber threat. including a malicious AI.
One is the engine of discovery. The other is the bedrock of truth.
Ask yourself, what is the true cost of absolute verifiable truth in the exabyte era? And what's the price we'll ultimately pay for ignoring the simple power of a light and a lens in favor of a perpetually complex and unsustainable system?
If the history of digital storage teaches us that increasing complexity always leads to an increasing probability of catastrophic loss or obsolescence, is the key to mastering the zettabyte era, not inventing something complexly new, but rather returning to the simplest, most fundamental, and most human-readable methods of the past.
Something to think about the next time you save a file. Thank you so much for joining us on this deep dive. Until next time, keep thinking critically about your bits.